Hello children, today we'll talk about the practical applications of heating effect of electric current. We know that the heat generated because of the electric current or electric circuit is used in two ways. So the one way is the heat generated in the electric circuit is all the heat is used, all the energy or all the heat is used. That is all the heat used, where it is used, whatever the heat generated because of the electrical current or the electrical circuit is used only as heat. Those are the electric iron or kettle, electric kettle, or we can say electric toaster and electric oven. So all these devices directly use the heating effect of electric current in the form of heat only. But we also know there are some devices which uses this heat to do the work done. What is like work done? Like we are talking about the devices like fuse, the bulb, the fan. So work done is like nothing but the glowing of bulb, and the remaining heat, rest of heat, is used to increase the temperature. So now we are going to in detail talk about the heating effect on such devices like bulb and fuse, because when the bulb is using the heat to do the work done, that is glowing, that is emits light, that bulb glows, that is useful property. But what happens to the temperature? The increase in temperature may damage the bulb. So what is the technique used to overcome this heating effect in the bulb? We are going to see in detail. So that is what you see. The electric heating is also used to produce light in a bulb. So heat is used to produce light. So what happens here? The filament, so we have a filament, must retain as much as heat generated to get hot and emits light. So the filament should make sure that it's getting hot, because that heat is only used to emit, some heat is used to emit light, that is a work done. So because of this very hot nature, the filament should not melt also. At high temperature it should not melt. So the filament, it will take the heat. The filament takes the heat, takes heat. So what happens here? Here the bulb glows or it emits light. Second thing, here the filament also getting hot. So then a correct material should be selected as filament which has which can withstand the high temperature and has a high melting point. So a strong metal with high melting point as used for making bulb filaments. So, and also one more idea is also added, that is they make sure that the filament is also thermally isolated using an insulator. The filament which is inside the bulb, this is a filament, it is surrounded by some isolating material like inactive nitrogen and argon gases to prolong the life of the filament. So the filament is now here is how the material for the filament is selected. On what basis? This is the question. So we have to talk about the second para. So what are the properties of the filament? Then the next question would be properties of the filament. So the next application would be in we use this heating effect or Joule's heating in the fuse. So why we use the fuse? We use the fuse because suppose when there is a high electric current flows through a circuit, when there is a high electric current goes into any of the electrical appliances. So what happens? So now this high electric current should be stopped. So to stop this, we use a place fuse in series with the device. We connect a fuse. So how the fuse stops the current? The next question. How the fuse stops the heavy current which is flowing, heavy or high current in a electrical devices. First point is it is connected with series with the device. Then the fuse consists of a wire made of a metal or an alloy of appropriate melting point. For example, that metal can be aluminium, copper, iron, lead. Sometimes if it is an alloy of tin is also used. Example of alloy is tin is used. Then if a larger current flows through the circuit, what happens? The temperature of the fuse increases. Yes. Then what happens? This melts the fuse wire. So when the fuse wire melts, since it is connected in series, it breaks the circuit. Because I have a fuse, if this is a fuse, if it is connected to a device called series, in series I connected to a, here there is a device, you consider this is the bulb. Or not a machine, washing machine. So when heavy current flows into the washing machine, the fuse will melt, so the series connection is cut. So when the series connection to the fuse is cut, again the washing machine also will not work because they are connected in series. So the circuit is broken. So that is what is explained here. The fuse wire is usually encased in a cartridge of porcelain, similar material with metal ends. Why it is encased in a cartridge of porcelain? Porcelain is an insulator. So in the bulb example, we also talked about the tungsten filament surrounded by an insulating material called inactive oxygen, nitrogen and argon gases. Same way, fuse, we give a cartridge like a layering above the fuse. It is done by a porcelain. Why porcelain? Because it is an insulator. Then what are the different value for the fuses? So basically it's current. So 1 ampere, 2 ampere. We have fuses on all these ranges. Now, for example, if there is an electric iron, if it is consuming 1 kilowatt power at 220 volts. So what will be the current? How I calculate the current? Current is 1000 by 220 amp, that is 4.54 amps current flows. So what will be the fuse? So the fuse, that is in a circuit, that iron, electric iron only needs a current of 4.54 amps. So any current which is greater than this 4.54 is will damage the electric iron. So what we do? So we connect a fuse. There will be a fuse which will be connected to the electric iron. So the fuse will sense the current. So when the fuse has a current of 5 amps, it will melt and break the circuit. So if the fuse melts and break the circuit, what happens? The electric iron will not work because the circuit is in series connection. This is a series connection. So we know if one series connection, if one equipment doesn't work, one part doesn't work, the continuous connections will not work because they are connected in series. So this is the concept used, the practical applications of electric heating effect of electric current. So now come back to where the heating effect is completely used. The heat is used only as heat in those devices called, you see, the heating effect of electric current has many useful applications where the temperature heating only is used. They are not used for glowing the bulb or anything. Only heat is used in iron, electric iron toaster, electric oven, electric kettle, electric heater, where only the heat is used. So you can see the electric kettle or the electric heater, where in a bucket of water they put the electric heater. That doesn't only have a rods. So here this connection will have only the electric circuit have only resistors. So you make a connection using only resistors. So more resistors. So what happens? Resistors will give you resistance. So high resistance is given by because of the resistor. Because of the high resistance, you have the high heat is high, heat produces high, so more heat is generated, more heat. And obviously we know in this concept, when high resistance, more heat is generated, only less current flows. That is the reason that heat is used for the devices like electric toast, electric iron, electric kettle. Hope you like this video, and we'll meet you in the next video. Please subscribe my channel and like the video also. Thank you.